There we go. All right, so as Matt mentioned, we're going to be going over ALERT2. It's a unique protocol that we use for flood management, and it can be used for other applications. But before then, I'm Kevin Smith. I do more of the support and then get into the sales. I'm out of Louisiana, outside of New Orleans, and with Matt, he's more sales and he supports also. He's out of Tampa. We cover all of the Americas. And as y'all know, we're out of Australia, and we're about, I guess, 17 hours away from them. And that's where I access engineering and technical support when some calls come in that I can't handle. So for deployments, we're well known for water wastewater. I'm going to go over this flood alert monitoring and alert system. We do get into power. We are getting into more and more of the IoT because our products can communicate MQTT. We also get into the oil and gas market because our product is class 1 Div 2, so we could get into well monitoring and then also into plants, petrochemical plants and refineries. So what is ALERT2? So ALERT2 is a system for transporting short data messages over radio paths. It uses a technology called TDMA in the newer version, the ALERT2. The original version, as they call ALERT or ALERT1, did not use this, and in some cases, some of the information got lost. But with the newer design, it gives you, with the TDMA, gives you a time slice that per your station that you can send up to 254 sensors and it's scaling back to a receiver. So this TDMA is also used in GPS satellite communications to keep the clocks accurate. So we use that also within the ALERT2. So it's mainly a read-only system. It's a protocol in a public domain that the National Hydraulic Warning Council uses in the States. We do have a big deployment in Australia that we do it for the whole country to monitor floods. And also, as you'll see, being able to use cameras and everything to see if bridges are able to be crossed and everything if you have a trip, like 3-hour trip. It does, this latest version increases the stations to over 65,000, which I thought was amazing. And each one of the stations, as I mentioned, can monitor up to 254 sensors. It does allow you per each sensor to select a data format. And for the first 13 sensors, it's predefined, but then after that, or custom, to where you could customize them the way you would like. So our version of it is at the top right side. Unlike our competitors, we have one unit that can configure to be a transmitter, repeater, or a receiver. So you can save a lot of money on spares. So with our competition, they have different ones per each one of those type of units. Our unit can be powered by a battery, external power supply, or you can actually connect a solar panel with an external battery to it. It has an integrated solar regulator to be able to do that. It does have options to use mil-spec connectors, or you could just use regular connectors. We have the capability of bringing in 2 analog inputs with a 24-volt power supply to provide loop power to those analogs. It has 4 discrete that can be discrete or pulsed inputs, and it has the capability of interfacing to SDI 12, which are smart sensors in more of the agricultural area. It communicates wirelessly on a licensed radio using 150 or 400, and we have options for cellular or satellite. So for accessories, we do have different mounting where you can mount it to a tree, to a pole. These are examples of sensors that interface to it. We don't supply the sensors, but these are just examples of what you can connect. So you can have a level, rain gauges, and a lot of different other sensors. As I mentioned before, we do have deployments in Australia that we interface cameras, and we have snapshots of screens that can be transmitted over the air. Here's an example of one of our installs. And like I mentioned, if it does flood a lot within Australia, but it's very spread out. So if you need to do a 3-hour trip, you need to kind of plan it. And this system will allow you to look at bridges to make sure that they're passable by looking at snapshots over the air. They do have disaster management software that the ALERT2 can be read into. What makes us unique is we have a decoder that can decode the ASCII data on the ALERT2 into Modbus registers, DNP3, or MQTT. So it does have the capability of data logging. So it can data log internally. You can actually data log into data storages over Modbus or DNP3. And with this data login, it has the timestamp. So for a system to work, you have to have 3 different pieces of equipment. You have one that is a transmitter out in the field, that is a field unit. You have the receiver that has the output of the ALERT2. And then in our case, we're able to do a decoder that brings in that ALERT2 streaming information and then be able to convert that into another protocol. And as I show here, I have a modem, but these 3 pieces of equipment is what's required for a system. But you can get into a large system, have multiple gauging sites, repeaters, receivers, and then have multiple decoders across your system. And as I mentioned before, 65,000, so it can be a large system. So for the decoder, I'm using a 115 E2. It's within our Condor line. That is only, it doesn't have a wireless solution capability. It's just Ethernet or serial. You could bring in the older ALERT1, but the newer ALERT2 into it, and then be able to convert that information out Modbus, DNP3, or MQTT. I have a demo that I have it converting that I'm going to show at the end that's converting to MQTT. So with the decoder, because the 115 E2 is within the Condor family, we're able to use this same decode firmware across our whole family. So we can use it on the 215, which is our Wi-Fi product, the 415, which is our license, and the 925, which is our unlicensed. It has the firmware in there to decode the ALERT2 protocol. So if you have an existing system and you want to add the ALERT2 to it, you can do that across the whole Condor family of products. So as a block diagram, the way my demo is set up is I'm going through the RS-485 connection, ALERT2, putting all those data points into registers, and then I'm going to go out MQTT. But as I mentioned, you can go out DNP3, Modbus TCP, or Modbus RTU, which makes us unique in with the ALERT2 product compared to our competition. This is just the front panel has LEDs on it. It has a power light, transmit and receive, has a sensor light for when you have SDI 12 or analog loop connected. And then it has a test mode where you can test the system by pressing a button. Internally to the unit, it's the area for the battery, but then you can also connect direct power or that solar panel and a external battery. It has a version, as I mentioned, with mil-spec connectors to where it's quick disconnects to different sensors. It also has in the internal part of the door, you can mount one of our 645M modems, or you can actually, we have options for a Iridium satellite module for secondary communications. If you go zoom in on the left side where they have the I/O, so here's the 4 points for digital or pulsed inputs, and they're not screw terminals, they're push terminals. If they have the mil-spec, it would be pre-wired for you. If not, you would have just a regular electrical connection to where you could pull your own cables and terminate. It has 2 analog inputs with that loop power. It has the connectivity right here for the SDI 12 smart sensors. And then also, this is where I've connected the decoder to where it can communicate the ALERT2 data over RS-485. The connection right here would be your power connection. I have a external supply, 24 volts connected there, but this is where you would connect your solar panel and an external battery. Here's a test button. This unit this USB is for firmware upgrades, and this right here is where you would configure it with a USB connection. So for installation, it has 4 areas where it's welded on here to where you can mount it to a pole using these mounting holes, or onto a tree or standpipe. And that's what this is right here, to where they have a metal plate that you mount it to, and then you put it in here, and then it's sealed. And this is examples of one of these in Australia that we have one of the units internally, and it's connected to the antenna. Here's another install to where it's actually like a pole mount to a structure. These are examples of the mil-spec connectors. Here's for the digital, so if you have a rain gauge for pulse analog, for the 2 analog, and it supplies the loop power. This is for a encoder, and this is for the power. So if you have external power, or if you have it to where you're using a battery and a solar panel. This is the connectivity for the smart sensor using an SDI 12 protocol. This is just showing you the simple text-based configuration when you connect to that USB-A connector. And this is how you configure the unit to be able to communicate over the network. We are in the process of updating this to a web server, but it's in progress right now. So as I mentioned before, of that 254 sensors, 13 of them are preset, but then after for 13 through 254, you can customize them. But this is set up to where you have the sensor type, and you select that from that text line code that I showed you for configuration. You have the different options, but then you also, per the option, you could determine what the resolution and what the scaling is. or the units. And for the 13 through 254, you could do the same thing. So as for the demo, I have a field station connected, well, wirelessly to the receiver. I have a physical RS-485 connection connected from the receiver to a 115 E2. And I actually have it connected to a cellular modem, but I don't have that working right now. But I do have it configured to communicate over MQTT. So to show that, I have to log in, and my IP address is this right here. It's a 115 E2. It's special firmware that has the latest firmware has this built into it. It has the gateway. And within this gateway, I'm able to select, depending on over the RS-485, usually we could connect Modbus or serial, but in this case, we want to, for ALERT2, select this ERTS IO gateway. Communicates 9600, data rate 891, have the input protocol coming in, and notice this checkbox. It is a license that key that needs to be purchased to activate this. So if anybody needs this, you give you the serial number of the 115 or any of the Condor radios, and then we give you a code. You key that code in, and then it should give this checkbox to show that, and it activates the screen. So it's communicating updates every 10 seconds. I have that binary output of the receiver, bringing it into the 115 E2, and I am setting it up for MQ, well, or I set it up for MQTT, but I could set it up for DNP3 and then also for Modbus if I wanted to. I internally set this up with the configuration of that field unit to where the actual address is 1000. The first sensor is 0, which is a rain gauge. 7 is level. 8 is voltage. And then it can go on and on to the 254. But if you're not using it, you put 255 to let you know that you're not using that sensor. So if I go to MQTT, here's what I have it set up as: rain gauge, water level, the RSSI, and the voltage. And I'm actually connecting to our 641M modem, passing the data to it, which I'll just show you at the end. And then I also have a remote MQTT server that I can send it to. But for now, I'm just going to show internally to the 115, and I'm going to monitor the communication. And it takes a little bit to update, about a minute or so. All right, so it's bringing in that sensor 0, 7, and 8, and this is the data. It's in the format of the MQTT. And then in a sec, it's going to send all of its data to show more information from a MQTT. But these are the settings that are set up within the configuration of the field unit. And as I mentioned, it can be up to 254 sensors. And then for MQTT, it's sending all of its information, and it's showing me some more information here with the battery voltage, the supply voltage, the RSSI, transmit. So they have a lot of other information. And just to show you, which I don't have it, I have it running, but I don't have a way of viewing the data right now, MQTT. I was setting that up with ignition right here, but I ran out of time. But you're able to transmit, as I mentioned or showed in the configuration. This right here is my 641M because I have a broker built into it. It's in beta format right now, testing, and it works great. So I'm trying to break it right now, and I haven't been able to, so it's all good. And let's see, so MQTT. And they have another one that I was about to set up that we have in Australia that I'm going to replace right here. But within all of our Condor radios, including the 115E2, we're able to have up to 4 MQTT clients. So does anybody have any questions?
Don't see any questions coming over at the moment, Kevin.
Okay, well, while we have a little bit of time, throughout, 10 months that I've been with the company, been getting a few different calls to be able to use our existing product, and in some cases, this product. And what I've noticed with some of these calls are for USGS and NOAA, they have a lot of applications out in the field to monitor dams, lakes, a lot of different things that are related to water. And what they're doing, USGS and NOAA, is wanting to know what the levels of all this is for data for the country, but then also it can be used down here, down south for hurricanes. So we're going to be meeting with USGS. They have a lab over here on the border of Louisiana and Mississippi. They're going to be moving that to the University of Alabama's campus. So I'll be able to get a unit in their hands, be able to test it. So in the future, for you guys, you may be seeing some need or some specs that have ALERT2 built into it. It is a unique system that, and I was amazed that it can communicate to 65,000 nodes out in the field. So it can be a large system, but the thing is, the ALERT2 is a special protocol, and it does require the decoder or a software package that can read ALERT2 directly into it.
Right, and with that being said, the governing bodies here in the U.S. Have pretty much led this type of monitoring up to the individual states. So the folks at the Army Corps of Engineers, NOAA, and there is an ALERT2 committee, but trying to
user group.
I'm sorry.
Yeah.
But I think the challenge that we're up against is, as I've mentioned, there's really no standard throughout the continental U.S. On how this is monitored. This is a protocol that's utilized, but I think there's a huge opportunity and upside to have a system that's been proven to be durable and reliable, and getting the Department of the Interior and the USGS involved is ideally the first step to go. So if there's any opportunities that anyone's seeing for this type of monitoring, please reach out to Kevin or I. And
Yeah, and just to add to that, wait, I'm sorry.
no, go ahead.
Oh, I thought somebody mentioned something. So the U.S. So for ALERT2, they have a user group, and we're part of that, and we're helping develop the actual protocol. So we're adding to it as we go, and that's every other year. They have a user group, and then they have a conference that they meet to discuss ALERT2, and then we have different papers written around that and updates. So I went to the last one, well, this year, that was in Colorado, to give an update on some of what our engineer manager implemented into the actual protocol. And just recently, and I need to get back with a customer, they have the need for monitoring the level underneath the manhole. So the problem that they have, that a manhole is made out of metal. They do make hard plastic ones, but the metal one, if we created some kind of penetration to where we have the antenna, and then add repeaters to repeat this signal remotely, we may have a solution there for a customer. So I'm going to be getting back in touch with them to see what they want to do. But with it being able to handle 65,000 and be able to repeat the information, you can have these within really a smart city type of environment, but then also being able to use it as it's intended for a flood monitoring. So, because what they want to do is be able to know before the manhole floods. So that's an example of a solution.
Well, I think there's the opportunities are endless, and just having the ability to provide a solution is going to be tremendous moving forward. It's just how do we get this on that contract vehicle and in front of the right people that are really going to utilize this data and information that this network can provide. So, but I don't see any other questions coming in, Kevin. So if you don't have anything else.
No, just if anybody sees the need for this, let Matt and I know, and we'll be able to show y'all a demo, or what we're doing is deploying some of them out in the field to test them.
All right, we will have this recorded and put on the LPro YouTube channel, where you can find any of our other previously recorded webinars. And that being said, I again thank you all for your time and look forward to working with you in the future.
All right, thank you guys.